Thank you for your presentation, and I invite us to make some questions. Yeah, Antonino.
It's very interesting, this report by Professor Manin, and I would like to point out that the Lagrangian of the standard model has nothing to do now with the frontier of our knowledge, because we know that this is a piece of the truth.
Sure.
So this was, in my review, one line. And you have correctly, it's very interesting, you have had the courage of writing 2 pages for the Lagrangian. And we know that this Lagrangian is not correct. We have the superpole. But this Lagrangian cannot tell us anything. Concerning about this very provocative question of you, what can science learn from Gaggle? The answer is nothing. Gaggle cannot tell us if the superworld exists, and we are sure that this is the big question to be answered in the following years. So what you have said is very interesting, but it is not going to be of any use to those who want to know the logic of nature. Thank you.
All right. Well, it was not a question, so I don't think I have to answer, but I just think that the answer, think, is universal. Google or no Google. And standard model, of course, I know that Lagrangian is already an old stuff, but Ptolemy's picture is also an old stuff. That was not a point. What I wanted to say is this fundamental division of a theory of our knowledge into 2 parts, Kolmogorov simple and Kolmogorov complex, that comes from the outer world. That was the point.
There was another
it's
question
very interesting,
here.
but this has nothing to do with the logic of nature. The understanding of the complexity of Kolmogorov does not help me in answering the basic questions which relate our intellectual activity with the understanding of the laws of nature.
Yes, I agree. I tried to say it from the start.
Yes, Phillips.
Well, I have a short comment and then a question. The comment is really to support and to amplify your point about Google. The characterization of correlation without causation as being something new, I think, is completely misguided. It's really something very old. It's what everybody did before there was science. They made correlations between why someone got sick and you know, what the moon was doing, and this came to an end, well, by and large, although, as we know, many people still believe these sorts of things. This sort of thing came to an end with science, and now what is being offered by this article in Wired magazine is a return to what appears to be a pre-scientific era, and I think we should certainly resist that. But I think this is in agreement with what you said. My question is this. It has to do with the nature of the Kolmogorov complexity. You've described it as being the size of the program needed to generate the text. But you also mentioned that with respect to, say, classical mechanics, that you could have a very simple program for describing the evolution of a 3-body system, but unless you knew what the initial conditions were to an unimaginable complexity, you wouldn't actually be able to predict what happened. That is, you wouldn't be able to predict the text. So what I'm missing is the difference between the Kolmogorov complexity and what seems to be some other underlying measure of complexity, which has to do with the what is necessary to specify the initial conditions. Is that also included in what you would call the Kolmogorov complexity, or is that something different that is overlaid on the Kolmogorov complexity, that is the ability to describe initial conditions, or whatever else might be needed?
No, it is a part of Kolmogorov complexity. If you speak purely mathematically, then there are 2 different kinds of Kolmogorov complexity. Kolmogorov complexity of well, let's say, texts or numbers or whatever can be an input into a program. And another part is Kolmogorov complexity of the program itself. They are very closely related. One can prove various inequalities between this and that and so on, but they are two distinct parts of the theory. And one more remarkable part, and it's what is usual with mathematics, the notion of Kolmogorov complexity is not only sufficiently precise, but it also we also can say in very exact words the degrees of imprecision of this version. For example, if you change the programming language, the Kolmogorov complexity in terms of this new program will change. But what one can say is that there is an optimal way of programming such that any other optimal way will produce only up to a constant the change of code. Second thing which is absolutely remarkable is that Kolmogorov complexity itself is uncomputable. So its Kolmogorov complexity is infinite. So this is a very interesting notion. It's much more precise than the well-known things about existence of unsolvable problems and things like that. It's a very interesting phenomenon in the world of pure mind.
So leaving apart that last point, which seems quite intriguing, it seems to me that what you've described as being the Kolmogorov complexity is very much what I think Jürgen Mittelstrass was describing as complicatedness as opposed to complexity. And so for example, one of the things that I think of as a physicist is I can have a simple problem, simple from the Kolmogorov point of view, in many-body quantum physics. Very easy to state, essentially impossible to compute the outcome, even though I don't need to specify initial conditions to any great degree. Just because of the structure of the problem, it's easy to say what the program is, but the program doesn't terminate in any time that is comparable to the age of the universe. So that seems to be a different kind of complexity than what is expressed with Kolmogorov complexity. Is that correct?
In a sense, yes, but what I wanted to say is that, of course, the strict notion of Kolmogorov complexity is a purely mathematical notion. It does not refer to nature, to anything like that. And I agree that this expressed in natural language distinction between complexity and complicatedness, I think in my metaphor, the division of scientific theory into two parts, Kolmogorov simple and Kolmogorov indefinitely complex, that my metaphor is probably a pretty good one for this distinction between complexity and complicatedness. I agree with that, yes. I just tried to see the things in a more precise way, although, of course, I lose certain intuitive characteristic that occur when we use natural language instead of mathematical language.
Let's finish here because we have a coffee break and it's already shrunken from 30 to 20 minutes. So please come back for 11:30 to continue the session.